Well, folks, the tornadoes dropped again in the U.S. The storms began while the sun was out and continued through the night and into this morning. We will combine the day-cloud phase distinction with the lightning overlay looking at the development of the storm system. And the story isn't much better tonight with convective atmospheric potential energy off the charts once again here into red, feeding that system to start up again here today. Eyes open, she is not done yet. Let's go to the sunspots, and this would be the microscale version of our recent solar fields examinations. The central dark umbra is surrounded by penumbra, which form linear-like features radially surrounding the sunspot umbra. The umbra is indeed where the arches, those magnetic fields, are confined as a tube at the penetration point of the photosphere, which means that the penumbral line electric plasma current explanation they currently give is about right on the money. Quickly getting into an abstract concept here, by compressing silicon and water, they notice that the distinction in character between the water and rock at high temperature and pressure begins to disappear. While some of you have heard that there's an ocean of water hiding in the mantle, this is how, and that could be an understatement, with even more so if you consider the core transition region. Cosmology note of the day goes back to the concept that they don't see it all, and when they do, the mass and structure and dynamics should make much more sense. Tons of galaxies in the early universe discovered to be rotating just like our Milky Way, but at that stage of the universe that was not supposed to be possible. Without radio waves, you can't tell how objects in space are spinning, and so there's a callback to our previous claim that they are indeed the future of astronomy. Up next, a superflare discovered at a star in our galaxy that would equate to about an X100 from our sun. That would melt every copper wire on Earth if it happened on the sun, and while we have seen much stronger superflares from dwarf stars, this star is much closer to the sun's maximum energy flare range, but while the sun does it about once every 1,000 years to Hallstatt cycle of 2,400 years, this star does it about twice every year. Of course, the lines begin to blur when you get much higher in energy blast. In fact, some of the strongest superflares are more energetic than many of the dwarf nova, Type 1 X-ray bursts, and micronova that we see. And in this story, we're going to be looking at a story of a progenitor. Kilonova are bigger than the smaller nova in the galaxies, but not quite supernova. But as part of gamma-ray burst events, I'm hoping how you can see that all of these different energetic things in space could actually be classified as different levels of nova. Last but not least, folks, I'm sure they wanted slightly better resolution from the Mustang Galactic Plane Survey, but it's actually not so bad given their wavelength choice and what they had to work with. It might be hard for you to notice the undulation and rippling of the wavy sheet, especially if your eyes want to train on the candy cane radio return on the right that became famous in recent surveys, but I'm hoping the overlay here will help discern the shape within the return there. Hard to believe something so basic about the tamer dynamics and instabilities of a plasma system could be the trigger of a recurrent disaster on Earth. If you scroll down just a bit below the video, you'll see our 2020 disaster playlist listed in the description box. It is also on our channel page here on YouTube and at suspiciousobservers.org. Every 12,000 years the disaster comes. The galaxy is the hand, the sun is the sword. The last one was about 12,000 years ago, and all signs you can see point towards our descent.